Hi students, this is Mr. Yao. Today we're going to talk about 2.7, where we will learn about graphing linear inequalities in two dimensions. So first, let's review a couple key concepts. When we learn how to graph on a number line, if it's less than or greater than, we used open circle. And if it was having an equal sign, less than or equal to and greater or equal to, we used closed circle. Now we also have learned how to change things into slope-intercept form, which is y equals mx plus b. So for example, the C, I'm going to solve for y, subtract 3x on both sides. That's 5y equals negative 3x minus 10. Divide everything by 5. Y is the same as negative 3 over 5x, and minus 2. As for the other one, solve for y, I'm going to get rid of my denominator first. However, this is not solving equation, so all I need to get rid of is the 4. So I'm going to multiply everything by a 4. Then I got 8 over 3x, that's 4 over 1, so 8 over 3, then plus that 4 over 1 just cancel with the 4, so just a y equals negative 8. Now I'm going to move the 8 over 3x over, so y equals negative 8 over 3x plus, minus 8. That is slope-intercept form, y equals mx plus b. Now let's move on to actual linear inequality. We graph linear inequality just like how we graph linear equations. That means we need to put the inequality in slope-intercept form, which is y equals mx plus b, before graphing it. Since we're graphing lines, instead of using open circle and closed circle, well, because if you use open circle, it's going to be like that. A bunch of open circle that's forming a line, which is not quite convenient. So we'll actually use solid line and dotted line. But we are still going to shade the graph to represent the final answer. If the inequality is less than and greater than, the line will be dotted. If the inequality is less than or equal to and greater than or equal to, the line will be solid. A dotted line is just a line like this. You can draw a lot of dots, or you can just do short dashes. That's fine too. We will use points to test which section we should shade on the graph. So we need to know how to determine if the ordered pair is a solution to the inequality or not. So let's do that first. We're going to learn how to decide if a point is a solution to the inequality or not. It's actually quite simple. We just need to plug into the x and plug into the y. Meaning, wherever you see x, replace it with, for example, negative 2. So 2 times negative 2. Wherever you see y, replace it with the 3. So minus 3 greater than 4. If you calculate the left side, that's going to be negative 7 is greater than 4. Well, negative 7 is not greater than 4, so that is not true, which means this point is not a solution to the inequality. Now the second one, plug in the 0 for the x and for the y. So it's 0 on the left side, greater or equal to negative 2. That actually is true, so yes, it is a solution. And number 3, negative x, or x is actually 5, so it's negative 5 greater than or equal to negative 5. Well, that actually works. It is true, so yes, it is a solution. You might be wondering, what about this 10? Well, this whole thing has no y, so we don't need to worry about the 10. Now let's see how we can actually graph. Step 1, we're going to rewrite the inequality into slope-intercept form. So solve for y, and subtract x on both sides. We got 3y is less than or equal to negative 2x plus 6. We're going to divide everything by a 3. That's y is less than or equal to negative 2 over 3x plus 2. That's the first step. Second step, we're going to decide if it should be a dotted line or solid line and graph the line. So in this case, it does have an equal sign, so we know it's going to be a solid line. So we're going to graph that line. 2 is right here, negative 2 over 3, so down 2 over 3, down 2 over 3, down 2 over 3. We have a lot of these points. This is a straight line, that's solid line. We're just going to connect them and make a solid line. Next, we are going to choose one testing point. The key is the point should not be on the line, and plug it into the inequality to check if it makes the inequality true. So for this one, you can choose any point, anywhere on the graph, with one condition, not on the line. So you can't choose that point, that does not work. So you can choose, say, like negative 6, 0, or you can choose, say, 2, 3, or you can choose the easy one, which is actually 0, 0. That's probably the easiest, because when you plug things in, you just get a bunch of zeros. And you can choose to plug into the original one, or you can choose to plug in this into this one, either one. So if you plug into the original one, that's 0 plus 0 less than or equal to 6, which means 0 is less than or equal to 6. So that is true. So if it does, or if it is true, you're going to shade the section that includes the testing point. Our testing point is 0, 0, right here. So this section includes 0, 0. We're going to shade that part. If it doesn't include the point, then you are going to shade the part that doesn't include that. So let's say you actually tested like 2, 3. That wouldn't work, so you are going to still shade the same section. The section that does not include the point. Now, number 5. Solve for y, so subtract 2x on both sides. So negative y is greater than negative 2x plus 4. You're going to divide everything by a negative 1. So y is less than, that's negative 2x over negative 1, so 2x. That's 4 over negative 1, so minus 4. So negative 4 is right here. And 2x is 2 over 1, up 2 over 1, up 2 over 1. We are going to get a lot of points. Let's get some more on the other side. And since it does not have an equal sign, we are going to draw a dotted line. Just a rough idea of a dotted line. Okay. And we're going to start shading. We're going to still use 0, 0 to test. That is totally fine. If 0, 0 is not on the line, a lot of time it could be the best point you check. So like I said, you can check in the original one, or you can check in this new one. That's our y, that's our x. So 0 is less than 0 minus 4. 0 is less than negative 4. Well, that does not work. Since 0, 0 is right here, that means we're not going to shade this section. We are going to shade the other section that does not include the point 0, 0. That's number 5. Number 6. There actually is a typo in number 6. Instead of the equal sign, it should be greater or equal to. So now we're solving for y. That means I'm going to need to get rid of the 2. So multiply everything by 2. That's 2 over 3x plus y, because that's 2 over 1, so they cancel, is greater or equal to negative 6. Subtract that to the other side. Y is greater or equal to negative 2/3 x minus 6. So negative 6 right here. Slope is negative 2 over 3. So down 2 over 3, down 2 over 3. Let's get some more points on the other side. Has an equal sign, so it's going to be a solid line. Now we can choose our point to test. Let's still use 0, 0, plug it in. That 0 is greater or equal to 0 minus 6, which is negative 6. So that works. I mean, 0, 0 actually works. So we are going to shade this section. Now, before we move on, let's actually go back. I know testing point is a pretty decent idea. So there's also another way we can think about this. Let's have a look. So whenever we have these tilted line, we actually have an upper side and a lower side. So if you don't understand what I mean, well, consider this to be like a shelter. Well, if you are actually up here and it's raining, you're going to get rained on. So that means this is the upper side whenever you are going to get rained on. If you are right here, well, if it's raining, then you won't get rained on, and that is the lower side. So that means it should be below. So for this question, you see the sign is less than or equal to, well, then we kept the lower side. So that means if it's upper side, it would have to be greater or equal to or greater than, and this would have to be less than or equal to. That's the lower side. Now let's check. For this one, if you are here, you're going to get rained on. If you're here, or inside the shelter, so that's the upper side. That is the lower side. And that sign is greater than, so that's why, well, actually not greater than. The sign after we finish solving is less than, that's why we kept the lower side. And number 6, after solving, it is greater than or equal to, so you see we kept the upper side because this is lower, because you can actually get sheltered in right there. So that's another way we can think about it. It is based on the sign, we can decide if we are going to shade the upper side or the lower side. But still, Even if you use that method to decide, you are still going to need to choose a point and check if it is actually correct. Number 7. Well, remember, the format we want is y equals mx plus b. So you would actually need y on the left side before you start graphing. So since you flip the variables, that means we also need to flip the sign. And if you're like, wait, but how do I deal with this? There's no y-intercept. Well, that is the same as y is less than or equal to 1 over 1x, then plus a 0. So 0, and then 1 up, 1 over. The line is actually right here, the diagonal. And in this case, you can see we are crossing 0, 0, so you can't use 0 as a testing point. You can choose anything else. So let's say we chose 4, 0. That's the 0, that's the 4. So 0 is less than or equal to 4. That works. That means we are going to shade the section that include this 4, 0 point, which is right here. Where you can see the sign is less than or equal to, so that's why we kept the lower side. Next, number 8. Well, this one, you don't see x. So that means it's not crossing x. Since we see y, that means it is actually crossing the y-axis. So the line is going to be a horizontal line, like that. There's no equal sign, so it is a dotted line. You can still use the point 0, 0 to check, and 0 is less than 4, so we're going to shade the part that has 0, 0, which is right here. That's example 8. Next, example 9. So whatever variable you see, again, that's the one you are crossing. That means it is crossing the x-axis. Same thing for number 10. Since it's a 3, that means it's going to be right here. And x is less than or equal to 3. Think about it. We actually have graphed something like this on a number line. If it's a number line, and let's say that's a 3, it's a solid dot, and that's the arrowhead, so it's pointing to the left. Well, now here, it's still going to be pointing to the left, so we are just shading that whole section. Next question, is 3, 0 a solution or not? Well, if that's our x, if you plug it in, that's going to be 3 is less than or equal to 3. That still works. Again, the symbol is less than or equal to. Since it has the or and the equal, well, that still works. So yes, it is a solution. If this is actually say x is less than 3, then no, it wouldn't be, because 3 is not less than 3. Number 10, x is greater than negative 2. So we draw the dotted line. If it's a number line, negative 2, the arrowhead goes to the right, so it's going to go to the right. Same thing here, you're going to shade the right side. As far as a solution, well, x is this one, so negative 2, well, 4 is greater than negative 2. That actually works, so yes, it is a solution. This question is just making sure you're not picking the negative 2. It's not like wherever you see negative 2 in the point, that is going to work, no. So last part, if you think about it, graphing x is less than or equal to 3 on the plane is almost exactly like graphing it on the number line. So yes, just like my example shown. Except instead of shading part of the number line, we are shading part of the xy plane, which are these are the xy planes. So that is everything for 2.7. Thank you.